Hi everyone, in this video we are going to learn divisibility test using prime factors. For this we are going to solve these two type of examples in this video. So our first example is the first number divisible by the second? Use prime factorization. So we need to find whether 735 is divisible by 21 or not by using the prime factorization method. So first we will find the prime factors of 735. Prime factors are 3 times, 5 times, 7 times 7. Now prime factors of 21 are 3 times 7. Now we need to find whether 735 is divisible by 21 or not. So for this, factors of 21 should be there in the factors of 735. So 3 times 5 times 7 times 7 divided by 3 times 7. Now we have 3 here and 3 here. We can cancel and get the 1. Same with 7. We'll get 1 here and we'll get 1 here also. So the numerator is 5 times 7 over 1 times 1. So 35 over 1 also can be written as 35. No need to write 1 in the denominator. So here we cut 3 by 3 and 7 by 7. This process is called the cancellation process. Now we will see part B, whether 432 is divisible by 32 or not. So here again we are going to do the factors of 432. So factor of 432s are 2 times 2 times 2 times 2 times 3 times 3 times 3. And factors of 32s are 2 times 2 times 2 times 2 times 2. 5 times 2. So we will divide 432 by 32. So factors of 432, 2 times 2 times 2 times 2 times 3 times 3 times 3. In the denominator, 5 times 2. Now we will use the cancellation process. So we have 4 2's in the numerator. We will cut those 4 2's with the 4 2's in the denominator. Now we don't have any 2's in the numerator, but still we have 1 2 in the denominator. So our answer is 3 times 3 times 3 over 2, which is 27 by 2. So here we can see clearly 432 is not completely divisible by 32. Now we are going to do part C. So 315 is divisible by 35 or not. So factors of 350s are 3 times 3 times 5 times 7, and factors of 35s are 5 times 7. Now we will check. So 315 divided by 35, which is equals to 3 times 3 times 5 times 7 over 5 times 7. Now again we will use the cancellation process. So 5 will be cancelled with 5 and 7 will be cancelled with 7. So we are left with 3 times 3 and in the denominator 1 times 1. So 9 over 1, which is 9. So yes, 315 is divisible by 35. So here we have our next example. LCM of two numbers is 180. Then which of the following is not the HCF of the numbers? So let's take two numbers 8 and 12. What are the factors of 8? 2 times 2 times 2. And what are the factors of 12? 2 times 2 times 3. So now we will find the HCF and LCM. To find the HCF and LCM, we will see the pair of numbers. So here we have two pair of 2, which is common. So HCF will be 2 times 2, which is equals to 4. And LCM is 2 times 2, and the rest of the numbers 2 and 3 also I'm going to write 2 times 3, which is equals to 24. So here we can clearly see whatever the factors are there in HCF will also be there in LCM always. So here also we will apply the same rule. The LCM of two numbers is 180. If 45 is the HCF of those two numbers or not, to find that we will find the factors of 45 also. If all the factors of 45 are there in the factors of 180, then 45 could be the HCF of those two numbers. And the same we are going to check with rest of the numbers too. So first we will find the factors of 180. And factors of 180 are 2 times, 2 times, 3 times, 3 times 5. Now one by one we will check all the numbers. So factors of 45 are 3 times 3 times 5. Now we will see the factors of 45 are there in the factors of 180 or not. So we have 3 and 5. All the factors of 45 are there in 180. So 45 can be HCF of these two numbers. Now we will check with the 60. So factors of 60s are 2 times 2 times 3 times 5. Now we will see factors of 60s are there in 180 or not. So we have 2, 2, 3 and 5. So all the factors of 60s are there in 180. So 60 also can be HCF of these two numbers. Now we will check for 75. So 75 factors of 75s are 3 times 5 times 5. Again we will check the factors of 75 are there in 180 or not. So we have 1 3, we have 1 5. But in the 75 we have one more factor as 5. But in 180 we don't have other 5. So 75 cannot be HCF of these two numbers. Now we will check with 90. So factors of 90s are 2 times 3 times 3 times 5. We have 2 here, 3 here and one more 3 and 5. So all the factors of 90s are there in 180. So 90 also can be HCF of two number. So here I have taken one more example on same. The LCM of two numbers is 252. Then which of the following is not the HCF of the numbers? So for this we will find the factors of 252, which are 2 times 2 times 3 times 3 times 7. Now one by one we will check all the numbers. So first we will check 14. So factors of 14s are 2 times 7. Now factors of 14, 2 and 7 are also there in factors of 252, 2 and 7. 14 can be HCF of these two numbers. Now we will check with 21. So 21 factors of 21 are 3 times 7. So we can see the factors of 21, which are 3 and 7, are also there in factors of 252. Here we have 1 3 and 1 7. So 21 can also be the HCF of these two numbers. Now we will check with 28. So factors of 28 are 2 times 2 times 7. So all the factors of 28 are also there in factors of 252. We have 2 pair of 2 and 1 7. So 28 can also be HCF of these two numbers. Now we will find the factors of 35. So factors of 35s are 5 times 7. So we have 7 in 35. We have 7 in 252. We have 5 in 35, but we don't have 5 in 252. So 35 cannot be the HCF of these two numbers. So here we have our practice questions. Solve this question and leave your answer in the comment box. Thank you.